pickup, which is also known as a transducer, is attached directly onto the component that is to be monitored. Once the transducer is in place, it can detect the amount of displacement, velocity, and acceleration that the component is experiencing. There are several different types of contact pickups available. Two of the most common types are velocity pickups and accelerometers. Velocity pickups consist of a fine coil of wire surrounded by a magnet. The magnet attaches to the component being monitored and vibrates at the same rate. The coil of wire, which is suspended by springs that dampen the vibration, remains relatively stationary. As the magnet vibrates, an electrical signal is created in the coil. This signal is then transmitted to a device where it is electronically interpreted as a measurement of velocity or displacement. Accelerometers work on a different principle. They have a small crystal located inside a casing. When the accelerometer is attached to a vibrating machine, the crystal also vibrates and produces an electrical signal. As with the velocity pickup, this signal is then sent to an electronic device where it's interpreted as displacement, velocity, or acceleration. Accelerometers are normally smaller and lighter than velocity pickups. Because of this, accelerometers are often used on smaller components where the amount of vibration would be affected by the size and weight of a velocity pickup. Since contact pickups can be moved from component to component during vibration testing, they must be mounted properly to ensure that the information they provide is accurate. This includes how the contact pickup is attached to the machine that it's monitoring and where the pickup is positioned. For example, the pickup should always be attached to a clean, smooth surface that is free of any material that could interfere with the contact between the pickup and the machine. In addition, many pickup manufacturers recommend using a silicone grease between the pickup and the machine being checked. This helps fill any gaps between the pickup and the surface of the machine to ensure that there is a large area of contact between the two. It also prevents the pickup from chattering on the surface of the machine. There are a variety of ways to mount pickups. Determining which method to use could depend on the type of machine being checked. For example, the pickup can simply be held in place by hand, or it can be attached with beeswax or double-sided tape. A pickup can also be attached with glue or epoxy. Some pickup devices are equipped with a small magnet that's used to hold them in place. One of the most successful mounting techniques involves bolting the pickup onto the machine being checked. Many pickups are designed with a threaded bolt hole just for this purpose. Unfortunately, nearly every mounting procedure has some limitations. For example, holding the pickup in place can prevent the accurate measurement of higher frequency vibrations, and bolting the pickup onto the machine can be time-consuming. In addition to knowing how to attach the pickup, it's also important to know where to position it. A few general rules apply, regardless of the type of equipment being checked. For example, the pickup should be mounted on the bearing housings or bearing caps. This ensures that the pickup will accurately sense the machine's vibrations, since these vibrations are transmitted from the rotating element through the bearings. The pickup should not be mounted on an unstable surface, such as this label. The label could vibrate more than the bearing housing or cap and interfere with the vibration reading. If the machine being checked has more than one set of bearings, each bearing should be checked if possible. Also, each bearing should be checked from 3 different directions. For example, this horizontal shaft should be checked from a point located parallel to the center line of the shaft, then perpendicular to the center line in the horizontal direction, and finally, perpendicular to the center line in the vertical direction. Checking from these 3 positions will provide all the information necessary. On a machine equipped with a vertical shaft, the readings are still taken from 3 directions. One check is made parallel to the center line of the shaft, another is made perpendicular to the center line in the horizontal direction, and the final check is also made perpendicular to the center line in the horizontal direction, but at a 90-degree angle from the second measurement. The point where the pickup is located on each bearing should be marked so that the same position is used on subsequent readings. If different locations are used each time the machine is checked, the vibration readings may be accurate, but they won't be useful for making comparisons with other readings.